Hello Internet, today we're going to be looking at scripting in Unity. Specifically, we're going to be trying to build scripts in Unity that can just run random arbitrary code to do whatever we want it to. And I've found a way to do this that I'm pretty excited about that makes this actually really, really easy. I found that I've got this working like an hour ago, and so still figuring out some of the kinks and kind of making it up as I go still. But I wanted to share this and kind of get some ideas on applications that people might have. I have some of my own in mind, but I feel like this has a lot of use cases. Before we go any further, though, this is embedding a C# compiler inside of Unity, and so there are some things that can be not so good with that. If you're embedding a compiler, you can run any code that's in that, and that means that anybody that you give this to is going to be able to run any of that code. This isn't probably going to be a problem locally. So if you give one person your game and it has this in it, that's probably not a big deal. But if you have the idea that it would be cool if people could like share their scripts and your game would just run it for people, probably don't do that, because this could, like, I'm going to be using this to like look up game objects in my scene, but you can also use it to say delete the entire file system or install a Bitcoin miner or whatever else, because it's the entire C# compiler inside of Unity. And so like it's really powerful, but it's probably useful more as a debugging tool or like a really weird niche feature in that kind of one-off game that is just a single-player experience than a multiplayer thing. There'd be a lot of security things you'd have to consider, and I don't know what those are. So that I just want to throw that out there because I feel like this is something that if you don't respect it, it could do bad things. So this is what it ends up looking like. I should show this. So I have two things running. One expects a double result. So any double comes out of this top script, and we get a result. And it's not, the game's not running, that's why. And you'll see I have nothing really in this scene. There's not much here. This scene runs at 10 FPS because every single frame I am recompiling this. And not ignore those errors. That's a different problem. And so you can see now the result of this script is 3. So we've gotten 3 back as that. And so now we can just say plug in 8 and we get 9. But that's kind of interesting, but we can do more than that. We can do math.pow of 2 to the 4th. Can we do that? No, we can't. So I have to do a fully qualified name and do system.math.pow. Do that. And it doesn't like it. Why not? Hold on. We can actually figure this out. So I have it logging out errors here. And why? Okay. It's wrong because this isn't compiling. So let's just make this a string. There we go. And so this is pulling our main camera. I don't know why this isn't working, actually. That's kind of weird. But okay. That didn't quite work out. That was a poor example, I guess. But you can do any normal operation and it just works. And that's because, yeah, all of that. But this second one is expecting a string. And I've included some extra stuff. So this actually has access to my Unity components. So it has access to the Unity engine stuff. And you can see that's already been pulled in. So it's already like I'm using a using statement inside of this script. So I don't need to do any of that. I've also pulled in like a link. So I can collect a whole bunch of things and concatenate them or do whatever I want. In this case, I'm just grabbing the camera and turning that into a string, which is what it's expecting out. And so effectively what this is you get a expected result, and that can be any type you want. It doesn't have to be a string or a double or whatever. That can be a game object, for example. And then from there, you just need some sort of string that you're going to compile. And then you also need to pass it in the references to what you're going to use. And so the script ends up looking something like this. So this is both of them. This longer one is the Unity one. And then this one on top is not the easier one. And so this is actually just explicitly running the script and expecting to return in, oh, that's why. There we go. That's what was wrong. It was expecting to return a double, and so it was wrong. We can probably get that math thing to work now. But this will still have access to basic C# binary stuff, but it will not have access to Unity, for example. So if I do system.math, that's included with normal.net. And so we should be able to say do pow of 2 to the 4th and get 16. And if we do like 7, we get 128 and so forth. You get powers of 2. And so this works, but if we try to invoke like a game object, game object find objects of type camera, and we try to give it like get the count of those, we get a whole bunch of errors. I have it debugging out the errors that we get. So if there's any compilation errors, it just logs those out for us. And there's a bunch of other things that are going wrong here. But this is not probably how you're going to use it. I hope this isn't how you're going to use it, because this is a waste of a lot of resources, but it works. And it's good for examples, so that's what we're doing here. You'd probably want to embed this in some sort of Unity UI thing and have like a run button or something. What I'm kind of picturing this as being useful for is like for debug builds, for example, in your game. You can actually use this, and so you can embed helpful scripts or something to pull up and easily debug specific things inside of your project. And so you can just run and access whatever variable or whatever function you need to access, and then test it out without having to go through a whole bunch of hoops to actually get that working. You can just build this right into your game. And so, yeah, this doesn't work because I haven't included Unity into this. Even if I do like Unity engine here, it's not going to know what those are, because it doesn't have this assembly as part of it. And so there's a lot of things that have to go into making this work. I had to pull a bunch of binaries into this manually, which is about as annoying as it sounds, but it works. Most of that is because Unity doesn't support NuGet, which is where these packages are meant to come from. And so I had to actually grab them from here, from Visual Studio, pull in a few different NuGet packages, grab the DLLs that were part of those, and then import those as resources into Unity. And so that's how this whole thing ends up working out. But the most exciting thing for me is this ability to interact with Unity, because this means we can actually interact with our game and not just run basic math functions or do like basic string formatting or whatever else we want to do with that. This gives us like full power. We can create new functions or whatever and expose them to this, and then effectively create an entire C# program from this. And so like we can do this and say if it's not null, do something, and yeah, I don't know what I'm doing. We can do whatever we want because it's a full language. And so I'm going to go into a little bit about how the more advanced thing is working, and then we can do, yeah, I guess I can show you how I got the binaries in there, and then I will leave it there. This is more like a, hey, look, this works, than a let's make a project out of this, because I just got this working. And so I'm just kind of excited, and I figured a lot of people would be interested to see this. And they'll probably have lots of cool ideas, so leave those in the comments and let me know what you think. So the initial part is the same here. The format for this is C#Script .evaluate async, which is going to create an async evaluation. It's going to use async await, if you're familiar with that. I'm inside of an update method, so I'm actually avoiding that using the get awaiter and get result thing to kind of force it to wait and then get the result. Don't do that. If you have like a button or something, you can just await and then use the event and call it back and do all of that. And you don't need to block your update loop to compile scripts. That's probably not what you want to do. This is a demo. But what you need to do is give it a type, and this is the output type. So if we're expecting to get, say, a game object out of this, we would do game object. And so that's going to expect some sort of Unity game object as the result of this script execution. And so then we just need to give it the script. And so we could do like game object dot get objects of type. And let's get objects of type, I don't know, scripting test. Why not? So we can just pull our own script out of that. That might actually be a bad idea. There's more work I'd have to do that, I think. Because I don't think our assembly is going to be included inside of this. I would have to test, and that just seems like it's going to be more work than I want to do. So we're not going to do that. We're going to get game objects of type camera again. And then we are going to grab the first one. So just do this. And let's actually use links. So let's do first. So that should grab the first element from this set of cameras. And then we want the game object off of that. So we're going to do game object like that. And I think that's correct. We can test that. The way I've been testing this is just doing this and seeing if we can do var game object equals that and see where it yells at me. Game objects of type doesn't exist. Find object. Oh, there we go. Find objects of type. It doesn't know what first is, but that's because we haven't included link. So this doesn't actually compile in our current scripting test thing, which is fine because we're going to include link into this itself. And so we can just run this in here. We don't need the semicolon because this is scripting stuff, so that's not there. And then we need to include some script options. And so there's a few other things that I haven't explored yet. One of them is globals. So you can actually provide hard-coded values, like let's say you want to include like X and Y and Z, or maybe a player object or something like that. You can include those as globals into your script, and then they can be referenced as like a variable. So you can reference, if you provide a player global, you could reference player to get the player. And so that gives you a way to kind of inject like standard things that are useful for this kind of scripting. There's probably really obvious ones like the main camera and the player, but there's probably others that I'm not thinking of. So in this case, we just need to make that script options. So I've done this before, so script options .default, and we need to include imports and references. And so those are two different things. The references is going to include specific assemblies that are going to include non-standard libraries inside of this compiled script. And then imports is going to statically include specific things or include the using statement of this. So those are actually going to be this. If you don't have the imports, you'd have to fully qualify every name. And that's fine, it's just more work. So we're going to do with imports. And let's do system, because why not? And let's include system.collections.generic. So this is just generic collections, and let's include link as well. So system.link and the Unity engine. So this is Unity engine is Unity's main namespace for things that you're supposed to be playing with inside of the engine itself that's actually running your game. You could include Unity editor, but that isn't included as part of your game when you actually build a binary. It's only part of the editor. And so if we actually tried to ship this out somewhere and tried to include the Unity editor, it would explode and have no idea what that was. So that should be enough there. Let's save this. I'm actually going to move this up to our start, just so this runs once, because that's all we needed to do. And it allows us to kind of separate that so we don't get a whole mess of things. And so we're evaluating async this thing, and we have with imports doing all of that. And now we need to add some references. And so adding references means you have to add the assemblies that you actually want to include. You don't need to include like system, for example, because that's part of .NET. But you do need to include things that wouldn't normally be part of it. And so that would be like link or Unity engine or things like that. And so the way I've done this is by getting the type of some object inside of that assembly. So for link, I just grab the enumerable type and then pull out the assembly. This is a reflection type. And so we're just getting the assembly reference for that object, which should link us back to system.link. And so that's one way to do this. I don't know if there's a better way. This feels kind of hacky to me, but it works. And that's sort of been the logo or slogan, I guess, for this. So we're going to try this and just do .assembly. There we go. And then type of Unity engine. And we need just anything inside of Unity engine. So we could do like transform, for example, and do assembly. And so that should include Unity engine and link. And then we're actually using those, so actually including using statements for those. And then we should be able to execute this function and get a game object out of this. And so let's create a public game object of our camera object. Sure. And so we don't need to initialize that, but I do want to assign to it. And so we're going to do something a little bit different here because in the previous ones, I was using this getAwaiter and getResult. And so typically these are async functions, which means they return a task. Tasks are not the result. They do not have any value yet. They're an async thing. And so they kind of represent work in progress. And so when we're calling these tasks, we're not actually getting results yet. And so by using this getAwaiter, we are getting the object that is actually capable of awaiting for the result. And then by saying getResult, we are effectively saying block until you get a result, which in this case, since it's in the update, we are completely stopping anything and waiting until we get a result from Unity, which probably isn't a good solution. It's a pretty terrible one. But what we can do here, because we don't actually care when we get this, we just need a result at some time, we should be able to continue it with something, right? Hold on. I should figure out how to do this because I didn't think this through and am just making things up. Oh, run synchronously. Does that do what we want? Sure it does. But it's just going to complete it. And so if we do like getAwaiter, getResult, that's going to keep the type moving forward. So we get a task awaiter of type game object, and then we get result, and that returns the game object. What we want to do is do something like await this. So var find camera task equals that. But this doesn't work. The reason this doesn't work is because we are not in an asynchronous function. We're not. In order to do that, we would need to add, not that. We need to do this and mark it as an async function. And I don't think this works in Unity, but we can try. Sure, why not? And so this find camera task actually isn't a task anymore. Because we awaited it, it's not a task. It's just the camera. And so we can actually just assign it straight to the camera object. And so if you're unfamiliar with async await, I'm not really going to go into it here. That's a little bit outside of the scope of this. But await, effectively, given a task as a result, will wait for that task to complete and then pass the information back. By marking a function as async, you're able to progress past that function and effectively take it out of band with the primary path of your program. All right. So now that we have this, we should be able to actually execute this and get a camera. I've made this more complicated than it needs to be intentionally. We could just do find object of type camera, but this lets us use like link and also like just use more stuff. And so it's either going to work or explode in our face. Because it is compiled at runtime, we don't know if this script actually works until we actually run our game. Even if like we don't get any compile errors, there's a good chance that we may blow something up. And so in order to trap that, I've been using just a try catch. And I think this throws a specific type of exception, but I don't know what it is. And I don't see it in here. So I probably should have grabbed the docs, but we can just catch an exception because why not? Because Pokemon exceptions are great. They're called Pokemon exceptions because you catch them all. And so now we want to debug.log warning. Let's actually log an error because all the other ones are warnings. And so this one will stand out if we just log an error. That's probably not the best way to do this, but again, example, so we're going to try it. So scripting test, do all of this stuff, should be able to reference this, and hopefully we get a camera out of this. And so our new value should have a camera in it, or it will all explode in my face. So one way to try and run this and see what we get. The main camera, cool. And so if I click this, you can see it highlights the main camera there. So we're actually able to get full references back out of this. And I can show you what happens. You can see there's some can implicitly convert type unity engine.camera to string. You're basically getting normal compiler errors out of this because you're using the normal compiler. This is the same compiler that is used if you're building .NET or something like that. So you should be getting pretty familiar errors. You will get some weird things, like if I take out Unity Engine here and just get rid of that extra comma, we will get some, well, I guess this one won't be that weird because I just took out the using statement for it. So it's just going to say it can't find game object, for example. The name game object does not exist in the current context because I took out the using statement for it. And that should be pretty familiar. But what you might not be familiar with is if I were to take out this and remove the assembly that we've included. If I don't include this, you'll see some different errors. And that's actually going to say something along the lines of can't find this, the typer namespace, unity.gameObject, and then gives you this massive thing. Could not be found in the global namespace. Are you missing an assembly reference? And then it gives you this massive stack trace that looks really scary because it's coming from libraries that are about code analysis and all this other stuff. That just means you're missing a using. And if you're not familiar with Unity's console, there's actually two panels here. This one can be scrolled up. So you actually get a bit of information here. It's not always enough, but there's a bunch of extra metadata here that will hopefully help you figure out what it is. Typically, the first line is what you want to look at. But hopefully you're somewhat familiar with this if you're looking to actually adopt this, because it's it requires a little bit of tinkering and playing around, and so just be ready for that. But yeah, errors slow things down immensely, but that's just normal Unity error things. Any kind of errors slow you down, and so let's fix this and get this back to a running state. And I'm just going to make this actually compile all the time. So we're just going to add quotes and then plus. So just concatenate two strings together, or in this case, stringify our camera object. And so now this should just work, and we shouldn't have any errors, I don't think. Yeah. So now there's no errors, and everything's just good. And I probably can delete these. There we go. We're still running at 14 FPS, so doing a good job there. But other than that, it seems to be working. So here is how I kind of got this working. There is a, let me see if I have it here. There is a this. This is sort of the page that I'm looking at. It's from .NET Roslyn on GitHub, and it's the scripting API samples. And so this is the package that you need. It's the Microsoft CodeAnalysis.CSharp.Scripting package. The problem is it's coming from NuGet, and NuGet doesn't work with Unity. They just don't work. So you can open up your solution for your Unity project and import this, and nothing will happen. It will still fail. And so in order to get this to work, you need to find all of the binaries for this and manually import them, which is what I've done here. And so what you're looking for is to match the binary type, the binary version, with the version you're using for Unity. So I got this working using .NET Core or .NET Standard 2. And these versions of the binaries are all compatible with .NET Standard. If I delete one of these, we'll get an error in one of the other libraries that a dependency is missing, unless we delete the code analysis like C#Scripting one, because that's the one that I actually need to run all of this. And so if I delete that, it's the furthest down on the tree. And so nothing else is depending on it. It's just depending on everything else. And so we can delete from there and it'll be fine. But for the most part, this is what you need. And I think I haven't checked the licensing on most of these, so I don't know if you can redistribute these. But for me, mostly I'm thinking of debugging stuff with this, not shipping this. And so the licensing there might be a bit different, but just because you're not redistributing things. But yeah, that's mostly it, I think. I'll give a link to the GitHub repo and the NuGet package as well. You can go and play around with that. If you have questions or want to play around with this, let me know, or join our Discord and we can chat. I'm probably not going to post any code for this because that would effectively just be sharing a bunch of binaries, and that doesn't make a lot of sense to me. So it's not, once you know what you need to do, it's not too difficult. It took me about 20 to 30 minutes to get this whole thing actually working, once I kind of figured out the library existed and that it would work. And then it was just kind of poking around and making things compile. And then you really just need to write some of this. And I will have some of these examples pasted into the description of this video. So you should just be able to grab some of these examples and use them. But I won't have the stuff for how to run that. So you have to watch this to figure that out. But yeah, that's mostly it. If you have ideas for what we could do with this, let me know. It's effectively a full C# compiler, so we can do a whole bunch of things. But I thought this was cool. I was really excited when this worked. And so yeah, that's it, I guess. So thanks for watching, and I will see you in the next video. So until then, see you, Internet.